the rarest blood types in the world. Welcome back to the realm of curiosities. Today we're going to talk about the rarest blood types in the world and why your blood type is far more complicated than simply A, B, AB, or O. Most people are familiar with 8 common blood types: A positive, A negative, B positive, B negative, AB positive, AB negative, O positive, and O negative. Among those 8, AB negative is usually one of the least common. O negative is also relatively uncommon but extremely valuable because its red blood cells can be given to patients of any ABO type during emergencies. However, neither is the rarest blood type on Earth. The familiar 8 types combine only 2 classification systems, ABO and Rh. The International Society of Blood Transfusion currently recognizes 48 different blood group systems containing hundreds of red cell antigens. Antigens are tiny structures found on the surface of red blood cells. Your immune system uses them like identification markers. If unfamiliar antigens enter your bloodstream during a transfusion, your immune system may identify the donated cells as dangerous and attack them. This can destroy the transfused blood and cause a potentially life-threatening reaction. That is why finding compatible blood involves much more than matching a simple letter and a positive or negative sign. One of the rarest known blood types is called Rh-null. The word null means that the person's red blood cells lack every antigen in the Rh blood group system. Most people know only one Are antigen, the D antigen, which determines whether their blood is labeled positive or negative. But the Rh system contains many other antigens. Someone with O negative blood lacks the D antigen, but they still carry other Rh antigens. A person with Rh-null blood carries none of them. This extraordinary condition is sometimes called golden blood, but not because it is literally golden or automatically valuable to everyone. Its importance comes from its rarity and its potential compatibility with certain patients who have unusual Rh antibodies. For someone with a rare Rh-related blood type, a unit of Rh-null blood could be life-saving. But the person who carries Rh-null blood faces the opposite problem. If they require a transfusion and have developed antibodies against common Rh antigens, finding suitable blood may be extremely difficult. They may depend on another Rh-null donor located in a different country. Rh-null can also affect the red blood cells themselves. Rh proteins help support the cell membrane, so people with this phenotype may have unusually shaped cells and mild chronic anemia. Another remarkable type is the Bombay Phenotype. To understand it, imagine that the A and B antigens are buildings. Both must be constructed on a foundation called the H antigen. People with type A blood modify this foundation to create A antigens. People with type B create B antigens. Type AB creates both. People with ordinary type O blood do not build A or B, but the H foundation remains. A person with the Bombay phenotype lacks the H antigen entirely. Because the foundation is missing, neither A nor B can be created. During basic testing, the blood may therefore appear to be type O. But it is not ordinary O blood. People with the Bombay phenotype can produce antibodies against A, B, and H. Since ordinary type O red cells still carry the H antigen, giving them O blood could trigger a severe transfusion reaction. They generally need blood from another person with the Bombay phenotype. This can turn an emergency into an international search. Blood services maintain rare donor registries to locate people with unusual combinations of antigens. Some rare blood units can also be frozen and stored for years, allowing them to be transported when a compatible patient needs them. But rarity depends heavily on ancestry and geography. A blood type that is exceptionally unusual in one population may occur more frequently in another. Certain antigens are associated more strongly with people whose ancestry comes from particular regions. This is why diversity among blood donors matters. A patient who requires frequent transfusions may gradually develop antibodies against antigens that are absent from their own blood. The more antibodies they develop, the harder future matching becomes. A donor with a similar ancestral background is more likely to share the patient's antigen profile, although ancestry alone never guarantees compatibility. This is especially important for people with conditions such as sickle cell disease, who may receive many transfusions throughout their lives. So what is the world's rarest blood type? There is no completely simple answer. Rh-null is among the rarest widely recognized phenotypes, but other extremely unusual combinations may be even harder to locate within a particular country or patient group. In transfusion medicine, rare blood is often defined not simply by an unusual ABO letter, but by the absence of an antigen found in almost everyone else, or by a combination of missing antigens found in fewer than one person in 1,000. The rarest blood is therefore not always the type with the smallest percentage on a chart. It is the blood that a particular patient desperately needs, but almost nobody can provide. Your blood may appear to belong to one of 8 ordinary groups. But hidden across the surfaces of your red blood cells is a biological identity made from hundreds of possible markers. And somewhere in the world, a person may carry a combination so unusual that only a handful of compatible donors can safely give them blood.